Okay, hello everyone. Welcome to the Shelter Heating, Cooling, and Lighting track. Today, our goal is to demonstrate novel low-energy, low-cost products and technologies supporting community resilience in face of disruptive events, including the COVID-19 pandemic. Our first invited speaker is Mr. Andy Buxton. Andy Buxton graduated in life sciences in mid-1980s and worked for many years helping optimize the performance and safety of military personnel working in extreme environments across land, sea, and air domains. He developed a particular interest in how low-energy cooling systems can help support military operations and came up with ideas on how to significantly improve their design. In 2000, he won the prestigious International Committee for Environmental Ergonomics Award for innovation with a novel computational fluid dynamics technique, the virtual mannequin for risk assessment. In 2005, Andy left government service to develop, manufacture, and market a microclimate cooling system for the mass market, the Sleepbreeze. In 2007 and 2008, he led his company to finalist position in regional awards for technological innovation. He's a past international editor of the Japanese Journal of Human Environment System. He now works in the digital arena within higher education at a leading UK university. He's now in the UK and sent us his recorded presentation. Now I'm going to share my screen so we can hear Andy's presentation. So I believe you are able to see the slide.
Good afternoon, ladies and gentlemen. My name's Andy Buxton. I'm the inventor of the Sleepbreeze cooling product. Before I start my presentation to you this afternoon, I'd just like to extend a grateful thank you to Dr. Lynn Wells for organising the 14th TIDES capability demonstration, and to Shima Mahibi at George Mason for organising the shelter heating, cooling and lighting track of this event. I wish you all the best for a successful event here over the next couple of days, and hopefully I can play a part in this by presenting to you on the topic of cooling people, not places. This is a topic very dear to my heart, and basically it explores the science and applications of how we can cool people down in austere environments using the minimal energy possible. Before I get into the presentation proper, thought it might be helpful if I just gave a quick biography of myself. For many years I worked in the UK Ministry of Defence as a scientific advisor. My particular interests were in low energy cooling systems for use in military aircraft. I helped design and validate the system for the Typhoon aircraft, which you can see in the picture on the right hand side. And during the first Gulf War, had a particular interest also in seeing how we could keep pilots cool in the Army Air Corps, who were wearing MBC equipment whilst operating in obviously hot desert conditions. So that's my particular interest. I moved on later on to see how I could optimize these systems, and from that gained a lot of knowledge which I applied to a slightly bigger problem, and possibly one that's of application to the StarTides community, where I was looking at how we could cool people down using a low energy system which would help them sleep and rest in environments where air conditioning is not a viable option. So that brought me neatly onto inventing the Sleepbreeze personal cooling product, of which I'll speak a little bit more now. So what kind of problem was I trying to solve? Well, we've probably all had experience where we've tried to get to sleep in hot, humid conditions, Could be a heat wave, for example, and we've not had air conditioning wherever we've been trying to sleep. We could have been on an expedition trying to sleep in a tent, for example. Again, obviously no air conditioning there. So we all know this kind of problem, that we just lie in bed all night trying to sleep. We're just hot and sweaty and it's really unpleasant. So why do we struggle to get to sleep when it's hot? Well, fundamentally, there's a circadian rhythm, a cyclical rhythm to the body's temperature. During the late afternoon and early evening, the body's temperature is at its warmest, and over the late evening, early hours, that temperature dips down, and we reach the nadir of our body temperature. It starts to pick up in the early hours of the morning, towards dawn, ready for the new day, and on it goes. Over the period of our evolution, the link between sleep and our body temperatures become intimately linked. So it's now actually a fact that we can't actually have onset of sleep until our brain temperature has dropped, and that's triggered by a general cooling in our body. So you can see why that might happen, that we want to sleep at night time and our body temperature is dropping at night time. So those two things are linked. When our body can't cool down because of environmental conditions, such as it's hot and humid, our body just can't cool down and allow the brain temperature to dip a little bit, so sleep onset is delayed. It's as simple as that. So that's why we end up struggling to sleep at night, and that's why we all feel tired the next morning. We're possibly less alert. So that's what we're trying to cure here. So oftentimes we've got access to air conditioning. Not so much in Northern Europe, I have to say. We're often less used to having generally hot temperatures during the summer period. We don't have air conditioning. Certainly when we go on camping expeditions, we don't have that kind of thing. But we kind of know implicitly that a small air movement across our bodies would actually promote us to get cool. Now the reason for that is quite simple. We're all lying there with a bit of moisture on our skin. If we can evaporate that through some air movement, there's a really powerful cooling mechanism through the evaporation of sweat that cools the blood that's circulating around in our body, that's close to our skin, that returns all the way around our body, goes to our brain, and that cools the brain down and triggers sleep. It's that simple. So basically, we, as a result of this, just a gentle air movement, we can trigger sleep. We can get a longer sleep duration because we got to sleep quicker, and perhaps we're higher alertness in the day that comes. That's really important perhaps for troops, for example, who might be going out on patrol. So the product you can see there, it's set up inside a mosquito net. At one end, on the top, on the right hand end there, you can see a little fan box, and there's a distribution duct which allows the air to go shooting down that duct, come out through the holes and just waft over the person. That's what it is. It sits inside that mosquito net, so the air is not bringing new flies and mosquitoes into where you're trying to get to sleep. So that's the product. It collapses down into a very small area, and basically it's very lightweight. It can run off a battery if you need it to, can run off mains electricity if you have access to that. So there are plenty of use cases for the Sleepbreeze. The ones we're obviously interested in this event are ones where we might be going out into environments where there's no air conditioning. Humanitarian aid workers, for example, could be deployed to a disaster zone. They're probably coming out of an office environment, going off somewhere warm and exotic, and they're completely unacclimatized to the local climate, so we need to support them in some fashion. We might be looking at more large-scale public shelters. We might be sheltering from a hurricane, for example. You can imagine the power grid fails. There's no air conditioning in that space for the people. They're all crammed in there, large numbers of people, all generating heat themselves. The conditions deteriorate, and it can become extremely unpleasant. So a battery-powered cooling system that's completely off the grid could support those vulnerable occupants of those shelters. Finally, and this is the one we'll be talking about today, is military military deployment. It can either be to a small-scale forward operating base, they're generally quite spartan, very few facilities, or it can be at a large permanent camp where we want to investigate the possibilities of fuel optimization. So, much like we have the TIDES demonstration back in 2011, the UK Ministry of Defence built themselves a forward operating base in the Eastern Mediterranean. It invited technologists to come in, demonstrate products that might help generate more energy in a sustainable fashion for use in large encampments. In my particular example, I was actually trying to save energy by showing how we could stop using air conditioning within the sleeping accommodation and rely slightly more on low energy cooling systems. And if you look on that little image there, one of the tents that I was holed up in is on the top right hand corner of this image. So what's the true cost of air conditioning? Well, we usually work on something called a fully burdened cost, and that has to include all of the assets that are required to move a gallon of fuel from the point where it's basically produced all the way to the front line. That can often cross hostile territory, so we need to think of all of the military assets that are involved in moving this product from A to B. That has a huge cost, financial cost and also a human cost. Ultimately, this is what we actually care about. We're trying to save people's lives, and it's been remarkably easy for low-tech explosive devices to be used to disrupt that supply line. As an example, we were moving 100,000 litres of fuel up to Camp Bastion each day, half of which that fuel was used on air conditioning. A significant amount of that fuel was used just to cool the sleeping accommodation, and over the 10 years of operation of that base, we probably used something in the order of $141 million of fuel just cooling down the sleeping accommodation. So what kind of way could we use a low-tech, low-energy cooling system such as the Sleepbreeze cooling product? Well, we came up with 3 strategies which they could have a play with. The first one was really simple. Basically, you switch the air conditioning off at night. You don't really need it in many circumstances. We looked at the metrology of Camp Bastion, and we figured that actually you could get to sleep with one of our products, which was using something like 6 watts of energy compared with something like 600 watts per person of air conditioning. So potential for a large amount of fuel saving there. The alternative one was to just basically say, right, okay, we will continue to use air conditioning, but we're just going to take 2 weeks off at the end of spring moving into summer, and take 2 weeks off at the beginning of the fall, and just rely on the Sleepbreeze there. So we're just compressing the amount of time when we're actually using air conditioning. Third one, really simple again. We're going to leave the air conditioning running. We're going to adjust the thermostat a little bit so it's just that little bit warmer, and we're going to basically cool the people down sufficiently using just a convective airflow. I can show you the relative merits of those based on computer modelling, and those roughly in the order of 10 to 4 to 1. So obviously, if you can switch the air conditioning off at night, that's probably your best bet. So what kind of business case does that stack up to? So in broad terms, the Ministry of Defence were looking at technologies that could achieve a return of investment within 3 years. Obviously, this is a product which is not hugely expensive. We were calculating, based on the figures I've just shown you, that we were actually achieving a return of investment within something like 4 to 44 days. So potentially, with minimal investment, ability to get a really good rate of return on that purchase. So that's obviously going to be quite attractive. So what happens next? We've invented the technology, we've made the product, we've developed a business case, we've even done a field demo as you've seen in those images earlier. All of that's hugely expensive things for us to undertake. But that's not going to be our biggest challenge. The greatest challenge we faced in getting this product anywhere was just in the simple resistance to change from the institution itself. There was bureaucracy. needless bureaucracy in many cases, and actually in some cases just pure apathy. We heard comments typically such as, yeah, we could save a load of money, but it's not my budget, is it? So I don't care. Well, actually, it's the taxpayers' money, and I do care. I'm a taxpayer. Other people who are out in the field, they say, well, actually, air conditioning is my right. I have a right to be comfortable like that. So, yeah, that's a valid point. But actually, when you make these choices in life, you're actually putting someone else in harm's way. And could you, with that knowledge, make a different choice? So, again, we're just trying to get the point over here that effecting change is going to be one of the biggest challenges, pushing technology out into institutions like the MOD. Sadly, this actually overwhelmed all our achievements, and we had to draw stumps on the whole project. Now, what are our learning points? So, basically, no one's going to be more passionate about your product than you are. Okay, that's a fact. You're going to face unbelievable barriers to changing behaviours. Be prepared for a long, hard fight to get your product into that market. Be resilient, and actually you're going to need deep pockets because these things are going to take time and a lot of investment. And actually, finally, what we had to do is say, well, okay, we're prepared to walk away from this, and that's what we did. So some final thoughts. You probably detected by my accent, I'm from England, and I thought I'd get the help of some famous local residents within my own village to help make this presentation more memorable for you. So first up, Jane Austen. Basically, the people that we're supporting with our product are going to be living in very rough, austere conditions. So any support we can give them to make their life a little bit more bearable is going to be hugely appreciated. And that's certainly the feedback we got from the soldiers who were using our product out in the field. Next up, Viscount Montgomery. I spoke about the need to make wise decisions. If you choose to use air conditioning and choose to use a lot of fuel, that's likely to go and impact someone else. So make wise choices. See how your choices impact other people, and then choose. Can we do things better, more sustainably? Finally, another local resident, Lord Baden-Powell, famous for saying be prepared, and in emergency management that's certainly what we should be doing. But actually this is an education experience for us all in the TIDES area, and I just wanted to say to you, learn from the things that we've learnt, learn from those hard lessons that our business faced, and be prepared to figure out how to do this so that you get the success and that the end users of your products get the success that they all need from you. So on that note, I'd like to thank you all for your attention this afternoon and to wish StarTides continuing success as it proceeds into the future, and bless you all. Thank you.
Okay, great presentation by Andy, and I really like to discuss use cases and lessons learned, which are very valuable. I wish he was online so he could answer questions, but is there anything you would like to add or discuss? Okay. Great. So I see Wayne is online. Hello, Wayne. Can you hear me? So our next speaker is Mr. Wayne Chiles, who is representing ShelterBox. In 2018 and in 2019, ShelterBox International was nominated for the Nobel Peace Prize for their work serving families displaced by conflict around the world, such as Syria, the Lake Chad Basin in Central Africa, and in Bangladesh. So Wayne, please take it away.
Thank you very much for the opportunity to speak to this group. Yes, I do represent ShelterBox in the Northern Virginia area. The project itself began as a Rotary Club project in Cornwall, England in the year 2000, led by a Royal Navy search and rescue diver who had spent a good part of his military career looking at survival and disasters and what to do about it. He realized that there was a missing element, which was emergency shelter. And so he created ShelterBox. We started as a Rotary Club project, shortly thereafter grew into an international charitable organization, standalone, with Rotary as a part of our process. Illustration here shows some of the types of equipment that we currently deploy. Initially, our deployment was the big green box that you see in the upper right corner. That's 2 feet by 2 feet by 3 feet. The standard family tent in the lower left corner. This is a third or fourth iteration of that. Blankets, tools, water filtration, cooking sets, ground sheets, mosquito nets, and about 2015, we added solar lighting. This is obviously a pre-COVID picture. The young lady holding the younger lady is one of our ShelterBox response team members. She is one of about 400 men and women around the world who have been through our extensive selection and training program to assume the role of ShelterBox response team members. They do a lot of things, but very simply, they're the angels who go to the disaster area, manage the disaster and the distribution, and ultimately they deliver a gift. It is a gift from our donors. It is a gift to families who have been displaced by natural disaster or conflict. And so in that role, they are the heart and soul of our organization. Our organization is unique because we do deliver hands-on. We are focused. Emergency shelter is our mission, and other essentials are supporting that, but shelter and getting families together are the critical elements. We go to faraway places. We don't just drop our equipment or deliver our equipment in the main urban area where the airport or where the materials are flown into country, but we make an effort to get out to the most remote families because we know they're the ones who will not be served if we don't do it. Different ways of doing that, all of them effective, some of them a lot harder to manage than others, as you can see. But the point being, we're going to work to get our equipment to the families who need it. Partners. We work with a lot of partner organizations around the world, organizations that share our values of the sanctity of the family and the need to get family units into a shelter. Because we started in Rotary, we've been close to Rotary. And in 2012, Rotary International and ShelterBox signed a partnership agreement. And we are the Rotary International only disaster relief organization around the world. Rotary, on its other hand, exists in 200 countries and areas around the world. And so when we go into a country that is struck by a disaster, frequently we have a local partner who can provide all sorts of assistance and support to our teams. We're going to send a few response team members, maybe a 4-person team, maybe a couple of teams rotate in the course of getting through all the government bureaucracy and processes. But we're a small organization, and having local partners is critical. During the first half of 2020, of course, the situation has been a little bit more challenging than in the past. In spite of that, we've been in 10 different countries. You can see them listed. We visited the Philippines twice. We're in the Philippines on an average about twice a year, to the degree that we have an operating entity with equipment and people physically located in the Philippines, so their response is much quicker. We've had to adapt, of course. That's not any surprise to anybody. We know that our tents and shelter kits provide security for the family, the ability to socially distance, and to have the family unit together. So that's a critical element. We've modified our practices. Before, we would send our team in and we would work with partners, and we would all be closely packaged together as we work through the process. Today, we distribute in smaller areas or to smaller groups of people at any one time. Occasionally, we even have a medical support person with us so that they can instruct the families on how to protect themselves, and also check to make sure that the families and that our teams are safe. We use protective equipment and social distancing just as much as possible. Our items that we deliver, as you saw back in the earlier slide, things that a family needs so that that family is self-supporting and doesn't need to interact any more than necessary with their neighbors. Cooking capability, water storage and collection capabilities, sleeping blankets, mosquito nets, basic things. And in recognition of the virus, we have added custom items. We are sending hand washing basins and soap so that the families have the opportunity to periodically wash their hands. This gives you a clue as to the places, what's going on more or less right as we speak. As you can see, we're spread pretty much around the globe. Call your attention to the countries labeled in purple, excuse me. We call that evaluation. That means that's the critical part of our program. That means that we are going back either physically or in many cases today electronically to reach out to the families that we serve to find out if what we delivered to them met their needs or didn't work the way they hoped it would, or whatever the situation is, so that we can learn how to continue to evolve our equipment. Jump forward. This is, well, actually I'm jumping backward. This is Vanuatu, April 2020. Cyclone Harold came to visit and wreaked havoc. Now, I have learned after I heard about Vanuatu that it's a long way from anywhere. Somebody said it was 1,600 miles from the nearest city. It's in the South Pacific, and we think of the South Pacific as a paradise, but maybe not in this particular situation. Vanuatu had not experienced any problems with the coronavirus. And so they didn't want people from the outside world to come into their country. So that added a challenge. How do we get our stuff there? Well, the final answer was we flew it to Australia. They shipped it to the main island in Vanuatu, and then natives and some of our partner organizations using small boats delivered our packages to the most remote islands. And the really important thing about that, of course, is that later, when we followed up with the village chiefs, they told us how surprised the residents were that somebody from halfway around the world even knew about their problems and cared enough to send aid. Jump to another critical area. The Lake Chad Basin of Africa. Nigeria, Chad, Cameroon, and Niger. The critical problem here has been ongoing now for almost 10 years, triggered initially by Boko Haram, and continues to be a situation where small villages are attacked. There is a refugee camp in the upper finger of Cameroon as it jabs between Nigeria and Chad. It's called the Minoweo Refugee Camp. It was set up a number of years ago, intended to serve upwards of 20,000 refugees. Today, that camp is still in operation. It serves approximately 70,000 refugees. ShelterBox is the only humanitarian organization that is providing shelter in that area. We have delivered a number of times, and again this year. Here's a young lady who benefited. Fanny was a Nigerian woman with her husband. She's 30 years old with 8 children. Her husband and her family were attacked. Her husband was injured in the attack, but he told her to get out of Dodge, and she did. And she eventually made it to the Cameroon border, and there she was picked up by security forces who brought her to the collection center. Now, you might imagine what a collection center would look like in this part of the world at this time with the crisis that's going on. And that she and her family were there for 3 months. And finally, she was allowed to go to the Minoweo camp, and ShelterBox found her and provided her with that tent. And today, she is at least safe. She has to collect wood to buy food to feed her family. You can imagine what that must be like, where everybody else is probably trying to do the same thing. Now, this organization, Star Tides, is talking about resilience. And I expect there are an awful lot of people, poor, destitute people, who are demonstrating what resilience really means. That is one of them. Our organization has been active in Syria since 2012. This is going on the 10th year of the Syrian refugee crisis. We've only been there 9. This is an indication of what has happened in the built up areas of Syria. Hospitals and medical professionals have been destroyed and displaced to the point where the refugee population barely has anyone to turn to. We have served in Syria for, as I say, almost 9 years now. We cannot actually go into Syria, but we have trusted partners who can deliver our equipment in that area. During the course of those 9 years, we've served over 250,000 people. This is sort of an image, I think, of what a collection center might be like, and you can imagine what that must be in a COVID kind of an environment. And this is an image of families who have received shelter. In today's world, according to the figures that I have, there are 104 million people who are currently displaced. Of those, about 75 million around the world are refugees. But of that total number, about 84% are women and children. And so we're talking about the most vulnerable people on our planet at a time when the crisis just continues. As Shiva mentioned, ShelterBox, for our work with refugees, has been recognized, nominated for the Nobel Peace Prize in both 2018 and again 2019. Just for the honor to be in that conversation is a powerful statement of what we're about. We are recognized by GuideStar and Charity Navigator. I have the website here, ShelterBoxUSA.org. You can go to that website and you can get buried in all the information and details that you might want. There's also this asset bank where you can get photos and stories and so forth to help elaborate on our work. And finally, my contact information. I may have met some of you. I've been a part of TIDES since it was begun in 2007, I think, or 2008. And every year I've set up my tent and showed my stuff. And this year, this is the best I can do. But I thank you for the opportunity.
Thank you, Wayne, for the fantastic presentation. You also covered your ongoing activities and how you adapted to the current COVID-19 pandemic. Any question for Wayne from the audience? Great. Please feel free to reach out to him if you have any question and if you would like to connect with him in the future. I think we can move on to our next presentation. So Wayne, if you please stop sharing your screen.
Thank you very much.
Thank you. Great. So our next speaker is Mr. Patrick Piper, the President and CEO of FarUV Technologies. We are very happy to have him today. Patrick, please take it away.
Oh, thank you. Yeah, I will. I'll share a few slides as well on some of the stuff that we're doing. Okay. So I thought I would just spend a few minutes to talk a little bit about far ultraviolet light technology and how it can provide a pretty significant step change in the role in eradicating respiratory disease in occupied settings. And really what we're looking at more particularly here is COVID, since it's more timely, but we've been working on this since 2016 with foodborne illnesses like E. coli or Salmonella, or hospital-acquired infections like MRSA and C. diff and a lot of these other diseases. But right now, the best practices that most people have are all defensive in nature. They're the concept of keeping yourself away from either airborne pathogens or pathogens that might land on surfaces. So it is keeping your distance, wearing a face mask, and hand hygiene. And what we're now adding to the equation is the concept of a narrower band of ultraviolet light that has been proven to be safe for human exposure. And that's kind of the big aha moment, or the big new thing here. In some ways, it's not that new. It is part of the ultraviolet spectrum, so it's not part of the visible light, but it is. It has narrower wavelengths than the UVB, ultraviolet B spectrum, which is sunlight, effectively. UVA and UVB are sunlight. And UVC is narrower bandwidth, and that's typically used to disinfect the water you drink, and in most municipalities. And then far UV is even narrower wavelengths. And the reason that becomes important is that those narrower wavelengths can't penetrate any human cell. And so what happens is they'll go through the air, and they'll be able to penetrate microorganisms, so viruses, bacteria, mold, things like that, but they can't penetrate even the outermost layer of skin. And so in so doing, they're safe because they don't hit the squamous cells, or they can't create melanoma because they literally never touch those cells. 254, which is the conventional wavelength of ultraviolet light, can still penetrate the outermost layer of skin. And so in prolonged exposures, it can lead to health hazards. And that's why UV isn't used everywhere today. But where the reason we believe 222 nanometers soon will be used everywhere, because it has been proven safe, not only in vivo and in vitro, but also in human studies and whatnot. And this has been studied in depth at Columbia University, as well as in Japan, but more recently also Harvard, Johns Hopkins, and the other leading institutions are looking at it. An important thing to realize is that this is not the safety levels that are prescribed for any wavelength of light has actually been known for decades. And so they're peer-reviewed maximum exposure levels to any light. And in our devices don't actually exceed those levels. If you have less than 22 millijoules per centimeter squared, it's considered safe with 222. 254 is considered a little more dangerous because, again, it can penetrate the skin. So that's more like 4 to 6 millijoules. On a sunny day, if you walked outside for even 5 to 10 minutes, you could get hundreds of millijoules per centimeter squared of UVA and B, which are penetrating even deeper. So it's not something that needs to be feared. It's something that just needs to be understood. And so a lot of what we find ourselves is just educating people on the safety thresholds that exist. And what's even more interesting, and of course has received a lot more visibility since COVID, is that it's very effective at taking out pathogens, whether it's bacteria or viruses. And in particular, coronaviruses are the easiest thing to kill with ultraviolet light, and in particular far UV light, because it attacks the proteins in those microorganisms. It can also treat things like the flu or MRSA or E. coli or molds and things like that. So it has a lot of efficacy against a variety of things. And like I said, we're not new to this. We've been working on this for some time. We have partners everywhere from Boeing to Columbia University Medical Center, MRI Global, and a whole host of supply chain partners. We've done lots of SBIR work with NASA and the Air Force. And we've been able to leverage those into several installations. And so right now we're installing pretty broadly throughout the military, Air Force bases. You can see the product here is best used as a ceiling lamp installation where it's treating all the air in the room plus the tops of the surfaces where respiratory disease or a contamination would happen. It happens when you breathe, talk, cough, or sneeze. Those particles come out, they land on the top of the surface. So a ceiling light, whether it's in an Air Force base or whether it's in my office on the ceiling here, as you can see, it can shine while you're there. It's a set it and forget it solution. You don't even need it. You don't even really know it's there after the day you install it, but it's continually cleaning the viruses and pathogens that might be, whether it's something, more dangerous like COVID or even just a seasonal flu or cold. This will have a profound impact on your environment. And it's not just the defense community we're looking at. We've been installing in buses across the country, in medical and dental clinics, in hotels, and everything from cruise ships and airports and beyond, and schools. So this is very rapidly expanding and becoming a more commercial opportunity. That some of the key differences in our solution versus what else is out there is that once you install it, there's no labor to apply. You don't need to have somebody go out and kind of wipe down a surface to do that. And as a result, you don't have to worry about them missing a spot on the surface either, because it's always going to hit the same surfaces. Similarly, it treats all the air and all the surfaces. So you're not really just doing one or the other, which a lot of different methodologies typically have their strength in one area and maybe they don't do another. So there's a lot of use of multi-layer type disinfection, which people are doing to try to create these additional thresholds of protection. And we're often used alongside some of the other solutions, and sometimes we're used alone. And when I say alone, I think people have all basically come to the acknowledgement that social distancing, masks, and hand hygiene are kind of critical three critical pillars. And then it's what can you do beyond that for the stuff you might miss, for the stuff where human error could influence that. And so that's kind of a general overview. I hope that's a decent start. I don't know if anybody has any questions or not.
Thank you for the very timely and informative presentation. Any question from the audience?
I like to do one if I could, Shima.
Oh, please go ahead, Scott.
I noticed your chart there. It said this didn't do whole room disinfection. So what does that really mean?
So it's a line of sight disinfection technology. So basically, from the light through the air and to the top of the surface, it will treat everything in that region.
Right.
But if it hits the top of your desk, it's not going to go through your desk and treat what's under your desk. It's like regular light in that way. And so it wouldn't treat what's under your desk. The good part about that is that in a respiratory illness, when you cough, breathe, talk, sneeze, it will land on the tops of the surfaces and not underneath. It's not going to land on the bottom of your desk. That's not where your potential contamination risk is. It is on the top of the desk. So with a ceiling light application in particular, it's the most effective at treating respiratory disease.
And most of us try to keep people out from under our desks as much as possible. So
that's yes, indeed.
I also have a question. So you might have touched on this. How costly is this product?
So the cost, these are a few of our different products. We have one that goes up kind of 8 to 11 foot ceilings, and then we have another one that goes up to 36 foot ceilings. The cost can be anywhere from about $2,500 per lamp up to $5,000, depending on how strong it is in the ceiling. But basically, when you think about how long it lasts, we'll cycle these lights. They don't need to be on all the time to create the disinfection. An average light in an average installation in an office space might last 1,000 weekdays. So your average cost of this light may be a little over a couple of dollars a day to provide that level of disinfection for either you or your customers if you're a business that is trying to protect both.
I see. Great. Any other question? Great. And thank you very much again for this presentation. I encourage everyone to reach out to you if they have any question or so I think
Okay.
we move on to our next presentation.
Thank you.
Thank you.
Bye-bye.
Great. Vinay, are you able to share your screen? So or maybe I should ask this question. Can you hear me?
There we go. Oh no, we've got echoes. Hang on, let me get multiple devices. Okay, I apologize for that moment of psychedelia. Oh no, I've got green screen turned on. What is going on here? Computer. Why does nothing ever work? There we go. Okay, is that doing what it ought to do? Can you see that clearly?
You can see the screen. So the last but not least, Mr. Vinay Gupta is going to talk about their exciting projects. Vinay is now in the UK, and we are very happy to have him today. So Vinay, please take it away.
Splendid. Glad to be here. So what I'm going to talk about is a really simple approach to kind of a radical transformation in how we do shelter. So the buildings that you see in front of you, although they look like architectural renderings, are real buildings. And they were built by people that I don't know who downloaded a set of designs from the internet and built the shelters for Burning Man, where they were going to be handling 110 Fahrenheit in the daytime sometimes, and as low as kind of mid-40s in the evenings. Very hot in the day, very cold, very high winds. And people took money out of their own pockets to build these things for fun. Every year at Burning Man, we do somewhere between 2,000 and 5,000 shelters. It's a little difficult for us to say because it's distributed. We count them on satellite pictures. And all of the materials are purchased from Home Depot. So the shelters that you see in front of you are, for the smaller ones, about $750 each. So under $500 in materials. But then there's a whole bunch of additional stuff you have to do to get them ready for Burning Man, which makes them a little more expensive. And the big dome at the back is 28 feet across and 14 feet high, and is something like $1,200 to $1,500 in materials. So these things are well established in the Burning Man community, but they didn't start at Burning Man. They started as a solution for long-term refugee housing. So the problem is that tents are great for emergencies like floods, where you have a single imminent immediate problem and everybody kind of piles in and you rehouse people, the floodwater goes down, everybody comes back in post-flood. This works pretty well. But most of the people we think of as being refugees are not going home for a generation, right? The civil war might settle down, it might not, it rolls on for a few years, repatriation becomes kind of difficult, and one thing leads to another. There are refugee camps in Africa when they're on their fifth generation of kids that have been born in the camps. This is how it is. As our friend from ShelterBox mentioned, this is an enormous global problem. We've got 100 million refugees, but what we don't really have is a decent approach to how we're going to handle refugees, given the fact that the refugee status is de facto permanent. And the NGOs can't really say that it's permanent, they can't really admit that it's permanent, because if they do that, they have all kind of problems getting host countries to actually take the refugees. So the whole thing operates in a kind of veil where we pretend the problem is not what the problem is, which is permanent accommodation for people. There's just no way back. So, next slide. Second problem is tents have a terrible supply chain. Like, if you have a really, really hard year, they simply run out of tents, right? The supplies like ShelterBox, they'll run dry relatively early in a bad year. I don't know if that's still true, but it certainly used to be true. And shelter stockpiling is incredibly expensive. If a tent is about $500, which is fairly typical, can be more, and you need tents for 2 million people, this implies that you had $1 billion tied up in tent stockpiles that you might not need. So what that creates is an incentive for people to kind of eyeball how many refugees they're expecting and try and buy as few tents as they can. And then in a bad year, what happens is they just ship all the money to Pakistan to the tent factories and they try and get as many tents built as they possibly can. And the whole thing is very, very lumpy and uneven and kind of unpredictable, which is not what we want. We want something which doesn't require an enormous amount of capital to be tied up in the tents, which are sitting around not being used, and we want something where shelter availability is essentially immediate. And we want the shelters to last a really long time because the people are going to be there for 2 decades on average. This is a tough situation. So here's what we do. We put up a website 15 years ago describing a quick way of turning 4x8 panel materials into shelters. So 4x8 is the standard industrial size for everything. Outside of America, it's 1.2 by 2.4 meters, 1.2 by 2.5 sometimes. And you can get basically any material that comes out of the industrial supply chain in that shape, from stainless steel through to paper. And this approach is very, very, just take the stuff out of the industrial supply chain. The roof pieces are half of a wall piece. The wall piece is a whole board. You literally just cut these things in half and off you go. And that approach is so simple and so predictable that anybody can do this. And when I say anybody, I mean there are literally tens of thousands of Americans who have successfully built these things for themselves and have been doing this enormous kind of long-run open testing. The slide that we have right here is from a project where they figured out how to pack all of the living systems for 9 families into a sea container. So shelter, bedding, furniture, and this was not intended for refugee use. This is just a bunch of people that like to do outdoor events where you have a whole bunch of people getting together for things like scouting activities. And they wanted something that was a little nicer than tents, and so they figured out how to containerize a Hexayurt. Really quite nice. And as I mentioned, as long as you have the ability to cut those boards on the diagonal, whatever tooling you need to cut the boards is all you need to make the Hexayurts. If they're made of plywood, you typically hold them together with screws. If they're made of insulation panels, which is very common, you typically hold them together with tape. And the tape that we use is an industrial tape called bidirectional filament tape. It has about a 400 kilogram breaking strain, and it's sold as Hexayurt tape now. So what I want to show you now, and excuse me as I do a little bit of faffing here, is I want to show you a project that actually uses the Hexayurt. Now, can I get this in? Can everybody see that okay? Is that working?
Yes.
Okay, good, thank you. So this is a project in Los Angeles, and Los Angeles has a crazy bad homeless problem. Crazy bad. Los Angeles County, I think 1 citizen in 200 is homeless. So it's a bad scene. One of the, somebody I know said, hey, I want to do something with the Hexayurt. I want to make something happen. So what they did was they put some money on the table and said, right, we're going to get somebody to build some Hexayurts in LA, and we're going to use them for homeless people to try and move this whole thing forward and fix the problem in LA. And so we found one of the folks from the Burning Man community that's really good at building Hexayurts. We hired them to go down to LA and build some Hexayurts. We found some volunteers to help, and we found some people that were close to the local homeless community that helped us figure out where we could site the shelters in a way that wouldn't cause too much trouble. And so we did it. And the whole project took kind of a couple of weeks for everybody to have a think about what to do, figure out who was going to do what where, find a site. And then the actual process of building them was literally a couple of guys, and it took a day to do 6 of them. So this is a really, really quick, easy, direct, simple approach where you can take available materials and available labor without a lot of high skill. Some skill helps. And you can just mass produce housing for practically no money. So that building, can I just get that up on full screen? Sorry, I should put this in the presentation. So that building right there is $350 of materials. It's about 14 feet long and about 7 feet wide. 6 feet high. It's got vents, it's attached to the ground by ties, the tape has been foiled over, so the ultraviolet light that we were just hearing about won't eat the tape. And that's probably good for easily 2 years, could be 5. And if we put a tarp over it to give it a little protection, or we painted it once in a while, probably another 5. If we'd built it out of a slightly more expensive material, which is a bit harder to get in a hurry, it could be out there for 20 years and it'd be fine. And I want to stress again, volunteer labour, commonly available building materials, and rapid construction. You don't really need shelter stockpiles. You just pull directly out of the industrial supply chain in the areas where you have one, the materials that you need. We looked at doing this for Haiti way back in the day at the earthquake, and we talked to Weyerhaeuser about getting enough plywood down to Haiti to rehouse 500,000 people. And they said not an unusually large order. We'd do about that size of an order to Home Depot every 2 weeks. So, the volume in the industrial supply chain is essentially infinite. The skills are universal. Any construction worker can do it. You just apply A to B and it comes out to be cheaper than tents. And it's cheaper than tents in terms of capital cost. But because it lasts years, whereas a tent lasts 6 months, the cost per person sheltered per year is maybe 10% of what it would be for tents, 20%. Could be as low as 5% or less if you build them out of really good materials. So, already did that. Let's just go down and take another picture. So here's a video of this being built. Oh, I apologize, the video is vertical, which always causes problems. And it doesn't, there's no real audio on this. They're just putting it together. So the manufacturing step is literally the same people that are putting it up, had a couple of trestle tables, they cut the boards in the pattern, and then they tape them together with this really big, thick, wide tape. And the manufacturing process is kind of annoying the first couple of times you do it. You look at the plans and you think this is going to take 10 minutes and it actually takes you a whole afternoon. The one after that goes pretty quickly.
You're not kidding.
Right.
That was so much faster.
Really simple. And then they just tape those 2 seams on the ends of the board, and then the shelter is up. So let me play you another video here. Now for this, I want to check that you can hear the audio. So let me know if you're having problems with the audio. I'm just going to double check I've got the Zoom thing set properly. No. Zoom. Where's it put the Zoom thing? Yeah. Okay, I don't know where it's put the Zoom thing. Come on, Zoom, where are you? Here, maybe? No, I can't see the controls for Zoom to check that it's actually going to play the audio properly. So if we've got problems with the audio, just let me know and we'll hope that it works.
Yeah, what you can do, when you start sharing your screen, there is an option that you can check that share computer.
Yeah.
If you do that, then you are good to go. You start sharing again, and then at the bottom, you see 2 options.
Machine sharing, advanced sharing options.
No, you don't need, when you click the green button, share a screen, and then at the bottom, there are 2 options. One is share the computer audio on the left.
I'm not getting that option, unfortunately.
Well, maybe tell me when you click the share button, what do you see on that? Okay.
Let's just give it a try. It's probably going to be fine.
Staying in the air.
When it's cold, it gets cold. When it's hot, it gets really hot.
Right.
But for the most part, it's a little, I feel a little sense of ownership. I got something. I got a place I can say, I actually do got a roof over my head. It may be made of foam, whatever, but nevertheless, it is my house. And, it just makes me anticipate having a real place of my own. So this is going to be my stepping stone to get to another place. It's better than here. Started with a backpack, And then I got a tent, and then I got this, and next thing is apartment or house. Other than that, it's created a lot of mixed opinions about it. People drive by now and stop, and they're either in amazement or at all, or just confused with what's going on. They don't really see it. What it is. People stop and ask. Even the police have come and asked what's going on. But so far, it's getting nothing but approval. I haven't heard anything bad about it. So I'm on the right path.
Okay, great. So,
How do you like staying in the yurt?
Well, it's luck.
sorry, I'm going to try and get rid of that again. Okay, so that's basically it. How are you doing for time? 30 minutes. So, come on, where's the Zoom thing gone? Come on, Zoom. So yeah, that's basically it. It's there. It works. They're used very large scale. There's a daughter project called ShiftPod, which is fully commercialized. You can buy them on the internet for about $1,500, and they fold up in a car boot. Those have gone into the humanitarian supply chain through conventional channels, and they do units that actual refugees are staying in long term. And the Hexayurt project just continues to circulate and slowly increase capabilities, increase our network, and it's one of these things which has an inevitability about it, because every year more people build Hexayurts, more expertise comes in, and we get deeper and deeper into the culture as just a standard shelter option. Like, well, if we need some shelter, why don't we just build Hexayurts like we do for Burning Man? There are now so many people that can say that those people will eventually start charities, they'll get involved in local government in the US. I think there's going to be a very large push to do this for homeless folks in the States as the homeless problem increases. And the critical thing about this is that it is really just open source technology. So the Hexayurt project has no bank account, it's not legally incorporated, it's a pure volunteer effort, and we did that so that we wouldn't be competing with other agencies for funding. And that means that anybody can come and access these designs and use them without the fear that they are potentially going to wind up bidding for a contract against us to do sheltering, or even for research budget. We just don't touch money. If somebody wants to use the design, they're welcome to it. If they don't want to use the design, do whatever it is that works for you. So it's very open, it's very decentralized, and I think it works pretty well.
That's great. And I'm really glad that you touched on supply chain issues. We're thinking about shelters and when the disasters strike, and then we try to respond. And so that part is important. Also showed us some case studies. I have one question, but before I ask my question, I would like to open the floor for the audience. Is there any question from our audience? Okay, then I think I asked my question. So you mentioned this is decentralized and universal skills, which are great. Now, if you use your imagination, what would be the next generation of shelters? What would be the perfect? For sure, we are building on our current strength, but what would you like to see as the next generation of shelter?
So there are kind of two directions you can go here. The first actually is that we integrate 2 or 3 of the technologies that we've already heard discussed today. So Andy Buxton's cooling technology has been an inspiration right the way through this, and I still have one of Andy's coolers which I use anytime that I'm going to a hot place and guard very carefully because that thing is irreplaceable. So getting Andy's tech back into circulation, now that solar panels are cheap, you take a cheap USB battery, you take a cheap USB solar panel, and you take a cheap USB fan, put it into the ducting that Andy designed, and suddenly these things become essentially air conditioned. And that's not a joke. Like Burning Man, they're doing this all the time at Burning Man. It's standard Burning Man technology, and it's probably 60 or 80 bucks worth of parts. The Burning Man units use evaporative cooling, so they're higher energy consumption and higher water consumption, but they'll take 15 Fahrenheit off the interior temperature of a Hexayurt, which is why people are so comfy in the desert. So if we build that little electrical grid for the unit, we can also get phone charging and we can get LED lighting. And at that point, it's probably $100 worth of bits for air conditioning, lighting, cooling, phone charging, and all of those components. Again, it's Amazon. Right, buying them retail, it's less than $100 a bit. If you were doing a large deployment, 25,000 units, and you took all that stuff directly from China in sea containers, the price comes down to probably a quarter of that. So, electricals, big next step. Materials, honeycomb polypropylene, incredibly thin, incredibly hard, not as insulating as the insulation boards, but way tougher. Goes together with bolts, and that makes construction really simple. None of this faffing around with tape, just you bolt the damn thing together. Waterproofing, you probably still wind up doing tape for waterproofing, but because the tape isn't structural, if the taping pattern is well designed, if you make a little mess of the tape, the water will still run off it. It won't run back up it because the tape doesn't have structural load. So that makes life much easier. And then the final thing is just, we kind of need to stop acting as if shelter is difficult. Right? Shelter is difficult because most of the agencies doing large-scale sheltering are just incompetent builders. If you look at the trash that went up in Haiti under the name transitional shelters, very poorly designed buildings from people with no real specialization because we have no academic practice of humanitarian architecture. So what happens is every time there's a shelter crisis, somebody calls their mate who happens to be an architect and says, hey, could you design us a transitional shelter? There's practically no lateral knowledge transfer between agencies about what works, and there's absolutely no institutional memory about how to do this stuff properly. Shelter Center in Geneva was meant to solve that problem, and it's an absolute clown show. So, my feeling is that basically we just need to do, act as if fixing shelter is a critical priority. We need to deal with the enormous humanitarian problem, which is everybody pretends the refugees are not here permanently, and they are. And we need to strap in because 10 or 15 years from now, we're expecting hundreds of millions of climate refugees. And we kind of need to get our game together here. Otherwise, when those people arrive, they're going to have nowhere to go. So yeah, that's my wish list.
That's great. I see one question from Walter Dorn. Impressive presentation. Many good points. And to summarize, can you state in 1 or 2 sentences what are the main advantages over tents?
Sure. So the first thing is longevity. Tents, ultraviolet light eats them, mold eats them, wind eats them. They just don't last very long. The other thing is, if you live in tents for a prolonged period in a hot climate, they're hell. They're just too hot to go inside most of the daytime. So what happens is you don't have a notion that you live inside of your house and then you go outside to do stuff. What happens is you get baked out of your house every morning and you actually live outside and you just have a place to sleep which is out of the rain. And that's not great psychologically for people. The real killer is cost, right? Every 6 months you have to provide a new tent, maybe every year if the climate's not so bad. And this really happens. Like Norwegian Refugee Council, they've got refugee camps where they've been sending them new tents every year for 15 years. So there's your first problem, right? Expense, longevity. Second problem is tents aren't really insulated. They do make insulated tents. UN buys them. There are huge kind of bales of kind of blanket material that are pinned up inside of an existing tent structure. And again, expense, mold, longevity. If you've got a whole bunch of people breathing inside of the tent, you'll get condensation. The condensation will form on the wrong side of the insulation, so it'll form between the insulation and the tent wall. And then the insulation gets wet and then it just turns black. And, the mold thing, it's really, really dangerous. Right? Nobody really is monitoring refugee health all that clearly. Nobody's actually picking up all the diseases being caused by this kind of mold issue. But I've seen those issues and they are nasty. So having something which is insulated, but is insulated in a way where if you get condensation, it forms on the inside of the tent, because the interior surface is waterproof, it's vapor-proof. At least at that point you can see where the moisture is, and if you're getting mold problems because it's a hard metal surface, you spray it with bleach and it's gone. It doesn't come back. So it's mold, it's insulation. Insulation is super critical. Pakistan, the UN wound up putting people up in metal half pipe, right? They put out tents, the tents blew over, they didn't have any insulated tents because they weren't stockpiled. They wound up, the only thing that they could find that would stand up to the snow load was metal half pipe. And if you can imagine being in the middle of a high mountain winter with a metal half pipe between you and the elements, you know, like, this stuff is just unacceptable. So it's a soluble problem. We need to get serious about solving it. Any country in the world has a plywood supply chain. If you want to build them in plywood and you want to insulate them, you build them in plywood, and then you get a staple gun and blankets, cardboard, bubble wrap, specialized insulation products. It doesn't matter what the hell you have. You just staple it up on the inside and now you have insulation. Does that create fire problems? Yeah, it creates fire problems. What do you do about the fire problems? You put smoke detectors in every unit. Smoke detectors, $5. It's not a perfect solution for the fire problem, but it's half of a solution. So, yeah, I mean, sorry I'm going on about this a bit, but, you know, like, we've actually thought about this, and if we've got to do hundreds of millions of people, we could get to the scale of doing hundreds of millions of people if there was available money in a year, 2 years. Right? The materials are in the industrial supply chain, the skills are simple, the scalability is basically infinite. We could rehouse the entire global refugee population for about $150 a head. So anytime somebody wants to get started, give me a call.
Great. Walter, any follow-on question? I take it as a
Splendid.
Great. Again, thank you again for joining in today. And I see Walter. Okay. Hello, Walter.
Oh, nice. That's cool.
And I see a note from Catherine Lasky. I have built a Hexayurt at GMU with a few students in about 20 minutes.
Yeah, it works.
It works, yeah. Living proof. Great. Okay, thank you all.